Okay, today we're going to be talking about reviewing for the 268 MathXL test. The very first thing we have here is finding the domain. So if we're finding the domain, this means that we need to go ahead and say, all right, the denominator can't be 0, so x is an element of the reals, and x cannot be negative 8. Yes? Okay. Okay, so we know what the domain is, so therefore the vertical asymptotes are going to be from the domain restrictions. Nothing cancels out, so that is done. So that means that x is equal to negative 8 is going to be my vertical asymptote. Okay, so if we look at the domain, n is equal to 0, and we look at m's degree in the denominator, and that is equal to 1. N is less than m, so therefore I have y is equal to 0 as my horizontal asymptote, whereas x equals negative 8 is going to be my vertical. So if I come over here to Desmos and I graph my function, I'm going to have 2 divided by x plus 8 and hit enter. I'm going to have x is equal to negative 8 as my vertical, and then I'm going to go ahead and have that y is equal to 0 as my horizontal. And if I go ahead and you can see that that's exactly what is happening there, yes? Okay. The next thing it's going to ask for is the limit. So the limit as x is approaching the vertical asymptote from the left-hand side, the y values continually drop. Do you see how they are dropping every single time? Look at that. It's getting longer and longer and longer from the x-axis. As x gets closer and closer to it, my y values are dropping down, which means this thing is approaching negative infinity. As you come over here and you look at it from this perspective, as x gets bigger and bigger and bigger, I should say, as x is approaching negative 8 from the right-hand side, from the positive numbers, my y values keep growing and growing and growing, so that is approaching positive infinity here. So that is why you're going to have that. So be very careful tomorrow whenever you're taking this test, or today. Okay, the next one is going to be look at the graph and figure out which one it is. So we're going to use a lot of things that are in our pocket here. Okay, so immediately I'm going to factor this, and this is going to be x minus a 7 times an x plus a 4. So my vertical asymptotes are going to be at x is equal to 7 and x is equal to negative 4. So if I look at my vertical asymptotes, I'm looking for a 7, which it could be A, it could be B, it is not C, and it is not D based upon our vertical asymptote. So the next thing I'm going to do is I'm going to say, okay, well, how about x equals negative 4? Well, these are all okay every single time so far as well. So A and B are both options. So now let's go ahead and find our horizontal asymptotes. The degree up there is 1, the degree is here is 2, so therefore my horizontal asymptote is going to be y is equal to 0. And both of those do have that. So the next thing I want to do is say, okay, what's different about these two graphs? Well, what's different is the y-intercept. So how do I find the y-intercept here? That's when x is 0. So that means I am canceling out all of the x's, and what I'm left with is going to be a 7 over negative 28, which is a negative 1/4. Which of these has a negative y-intercept? It cannot be A, which means my answer is B. Okay? Now, I lost, hold on 1 second. Okay, so we want to find the domain, the asymptotes, and all the intercepts of this graph as well. So immediately, I'm going to go ahead and say, okay, I know what my domain is. My domain is going to be x is an element of the reals, and x cannot be negative 4. I don't have to factor that. Then I need to find my vertical asymptotes. Factoring this, I'm going to get that numerator. Nothing cancels out, so therefore my vertical asymptotes are exactly the domain restrictions, so therefore x is equal to negative 4. Next, I'm going to be finding my horizontal asymptotes. My horizontal asymptotes are found by comparing the degree of the numerator, which is 2, with the degree of the denominator, which is 1. N is greater than m, so I have no horizontal asymptotes. If I have no horizontal, I have the potential to have a slant. And since n is greater than m by 1 unit, I do have a slant asymptote. How do I find that? Well, I'm going to do this exactly the way you would do this if you were to be doing long division. So this is x plus 4 goes on the outside, and x squared minus 9x plus 18 goes on the inside. What do I multiply x by to get an x squared? An x. X times x is x squared plus a 4x. Then we're going to go ahead and change each of those signs, and those cancel out, and I have a negative 13x plus an 8. Okay. 18, sorry. Then I'm going to go ahead and subtract 13 from that, so I can get a negative 13x plus a negative 52. And again, I'm going to go ahead and change those signs, making those both positive. Those cancel out, and you're going to have a 70 as my remainder. I do not need that 70. So my slant asymptote is y is equal to x minus 13. Okay? The next thing I need to find is going to be my x and my y intercepts. The x-intercept is when y is 0. So that means you're taking the numerator, which is x minus 6, and setting that equal to 0, and x minus 3, that equal to 0. So x is equal to 6 and 3. So I'm going to have 6, 0 and 3, 0. Okay? My y-intercept is literally whenever all of your x's are gone and you're left with an 18 over 4, which reduces down to a 9 over 2, which gives you the point 0, 4.5. So be very careful. Make sure you're watching how MathXL wants you to put that in. Okay, the next one we're going to have here is finding the asymptotes of this, and I'm going to go ahead and say domain first. Before I do domain, I am going to factor this because I see stuff in the denominator. This is x minus 5 times x minus 5. Now, what does that mean? That means that x is the element of the reals is my domain, but x absolutely cannot be the number 5. To find my vertical asymptotes are found by seeing if anything in the top and the bottom cancel. Nothing does. So my vertical asymptote is exactly my domain restriction. Now again, I'm going to look for my horizontal asymptote. N is equal to 1. M is equal to 2. So that means N is less than M. So I have Y equaling 0 as my horizontal asymptote. Now for a second, your brain needs to understand something, that this is the x-axis. So what does that imply about our x-intercepts? That implies that I don't have any x-intercepts. Okay? Before I get there, I need to do my slant. My slant asymptote, well, I have a horizontal, so I can't have a slant, so that's none. My x-intercepts means I'm taking my top, and I'm going to set that top equal to 0. So that means x is equal to negative 7. Now, these two contradict each other. So something funky is going on with the graph, so you need to make sure that you're paying attention to that. And then lastly, we're talking about our y-intercept. Our y-intercept is going to be the point on the graph when every single x goes away, and I'm left with 0, 7 over 25. Now let's talk about that graph for a minute, because this graph is exactly the same. There's 4 graphs here, and I want you to pick which one of these is your answer. So MathXL part A, B, C, D, and E is going to be this part, the first slide over here. And then over here, it's going to ask you, based upon that information, to figure out which one of these is correct. Well, we have one vertical asymptote at the number 5. So it could be A, it could be B, it cannot be D, and it could be C. All right, so now let's talk about something else. I have a y-intercept over here of negative for letter C, so it can't be that because that's negative. It can't be B because that's negative, which means it has to be A based upon my vertical asymptote and my y-intercept. Okay, so that saved us a lot of time. Okay, next, this one right here, same concept. Domain, well, it's very simple. X is an element of the reals, and x cannot be 0. This right here, I can't factor that, so I am stuck with it exactly the way it is. So my vertical asymptote is going to be exactly my domain restriction. My horizontal asymptote Well, this is a 1 and that's a 2, so n is greater than m, so this is none. Now my slant, well, I'm going to find this exactly the way we did it last time. That means I'm going to have x on the outside and x squared plus 0x plus 64 on the inside. I'm going to multiply by x to get an x squared. I'm changing that sign, that goes away. And I'm left with 64 as the remainder. So therefore, I simply have a slant asymptote of y equals x. Okay? So I don't have any y. This is the y-axis, which means now I'm not going to have a y-intercept. Well, why do I not have a y-intercept? A y-intercept comes when all of my x's are equal to 0. So that's 0 squared plus 64 over 0. So that's 64 over 0. You can't divide by 0, so that is not possible. So that is why I have no y-intercept, because I have a vertical asymptote on the y-axis, which is x equals 0. And the last thing that I need to find is my x-intercepts. And the x-intercepts is whenever I have x squared plus 64, which is my numerator, equal to 0. That means x squared is equal to negative 64. And if I take the square roots of those, I'm taking the square root of a negative number, and that puts me in the imaginary number system. So I don't have any x-intercepts either. And if I come over here and I graph this for a second, it gives us a really good idea of what it's supposed to be. And I'm going to have an x squared plus 64 over an x. And if I do that, this x equals 0 is what I should have there. And then over here, I'm going to have an x. And if I go back to my home and hit that, you can clearly see that something's going on here. And then if I zoom out, you can see that it's never crossing the x-axis, it's never crossing the y-axis, and you can see that graph there easily then. Does that make sense? And the last thing I want to talk about before you take your test is this right here. And this is basically use the data shown in the graph to find a quadratic regression equation. Then predict the box office revenue in 2011. Understand that it represents since 2000. Okay, so if it represents since 2000, that means I'm going to have, this is 4, this is 5, this is 6, this is 7. So I'm going to have 424.3. I'm going to have 5, 23.4. I'm going to have 6, 25.2. And I'm going to have 7, 26.4. Now, we're going to go ahead and do regression on here. I'm going to put these both over here together so that we can see them easier. I am going to come over here and turn these off, and I'm going to make a table. So I'm going to have 4, 5, 6, 7. I am going to have 24.3, 23.4, 25.2, and 26.4. So I'm going to graph that, and you can see it right there. It's asking for a regression model, so that is going to be y1 approximately ax1 squared plus bx1 plus c. And whenever we have our equation, make sure you are careful and you're watching what it says to do in MathXL, because this is the rounding 3/10 places. So this is to 3 place values, sorry. So that's y is equal to 5.525x squared minus 4.965x plus 35.595. Now that r squared value is terrible. If I take the square root of that, you can clearly see that that is going to be a terrible number there. That is 0.8895, and you have a 94.31 as your R value. And it's not touching very many points. You can see that it's not going to be the best projection, but we still have to type it in. So y is equal to 0.525x squared minus 4.965x plus 35.595. So there's my equation, and then I'm going to go ahead and click up here because I need to do a prediction, and I need to know what happens in 2011. And what happens in 2011, again, be very careful, because is it asking for 2011? It might be asking you to round to the tens place, so that's going to be 44.5. If it's asking for the hundreds place, 44.51. If it's asking for the thousands place, it's going to be 44.505. So just please be very careful and read exactly what it's asking you to do. If you have any questions, we will be sure to go over some of those tomorrow in class if you need them. The tests, just be careful and make sure you are reading. Okay?